Here's another question on resolution of a vector, but it's slightly different compared to the others. It says force P and Q are drawn to scale on a Cartesian plane shown below. So here's the force P and force Q are drawn into scale. So you can also see the components of force Q and force X. Now let's look at force P. Force P, it has the components, which is the horizontal component there, which is Fxp. It's what? It's 2, right? It's 2 newtons. And then the force, the force, the vertical component of vector P, it's upwards. As you can see, this is vertical components for vector P. Now, the angle between the angle or the direction of the resultant there, it's to the horizontal. Let's look at force Q. Force Q, it has the components as well. It has the components there. The components there, it's let's use another color. The components for vector Q, it's Fx. It's Fx Q, it's going to the left. And then the components for vector, for vertical, the vertical components there, which is Fyq there. Those are the components that we have. And for the component for Fxq there, it's 3 newtons to the left. And the vertical component there, it's 1 newton downwards. Right, now let's answer the question. 2.1, it says define the term resultant vector. The resultant vector, it's a single vector having the same effect of 2 or more vector together. Exam guidelines strictly when it comes to that. 2.2, it says use the calculation to determine each of the following: the magnitude of vector P. Now to get this magnitude, guys, you have 2 adjacent sides, this side and this side, those 2 vectors. That means we use the theorem of Pythagoras there. So the vector Q there, guys, in order to calculate that, so we'll say it's a force what? Force P. We'll use the theorem of Pythagoras there. The theorem of Pythagoras, we'll say Fxp square plus Fyp square. This is 2.2, guys. And so there, what we're going to have, the Fx, it's 2, this magnitude there, it's 2, and the Fx, the Fyp, it's what? 4 square. So the answer there, when you punch that in the calculator, it will be 4,472 newtons, right? They didn't ask the magnitude of that, but the magnitude of direction of that, which is this. If they wanted the direction, they will use 10 theta, which is Fyp divided by Fxp. How do we know that? It's opposite over adjacent, which is taller, right? Which is going to be there's a -1 there, which is going to the opposite. It's 4 divided by 2. 4 divided by 2, which is, it's a second function, 10. 4 divided by 2, it's 2. So the angle there will be 63,43 degrees there. Okay, that was not the question. Let's move on with the question. 2.2.2, it says calculate the direction of vector Q measured clockwise from the positive. Now, when they say calculate the direction measured from the clockwise positive, which is from here, so we want the direction of vector q this way, from the north, to there. So guys, what is that? It's the bearing. And the bearing, when we calculate the direction of this, guys, of this vector p, it's there, the angle is there, but we want it from there, from the positive y-axis to there. So it's going to tell us what is this angle. So guys, by doing it this way from the positive, that's the bearing method. The bearing method, we always go clockwise, and we start from the positive y-axis. So we want this direction is 90, 180. We know the entire there, it's going to be what, 270, but this angle is going to be less than what, 270. So we'll say 270 minus this. It will tell us what is this angle from there to there. Okay, let's do it, guys. Let's do it. How are we going to do it? We must first get this angle here. So we will use the trig ratio that says opposite over adjacent. That's what we have. The opposite is here is 1, and then the adjacent is 3, but they're opposite. So let's calculate it here. It's 2.2.2. So we'll say tan theta angle is equal to tan theta second function. The opposite here, guys, as I've mentioned, is going to be fyq divided by fxq, and then it will be the fyq, it's -1 divided by -3, and this is -1 divided by -3, its opposite, which is -1 over -3. So the answer there, it's going to be 18,43 degrees. But they don't want that, guys. The angle that is 18,43, it's this angle. Sorry. But they want it from there to there. So now, having this angle here, we can say 270 minus this. It will tell us this angle from there to there, right? So what are we going to do now? We'll say, therefore, this angle is what? 270 degrees minus 18,43 degrees. So the answer, it will be 251,57 degrees. This simply means that from here to here, it's 251,57 degrees. Alternatively, what you can do there, you can calculate. Okay, let me erase all these. So that we can see. Okay, you can calculate this angle, right? This angle. So calculating this angle, that means we're going to say 180 plus this angle that we're going to calculate. So calculating this angle, how are we going to calculate it? We'll say this angle is going to be opposite over adjacent. So our opposite here is fxq, and adjacent is going to be what? fyq. So it's going to be tan theta -1, which is going to be, what is our opposite now? Opposite now, it's fxq. fxq divided by fyq. Then your tan theta, it's going to be negative 3 over negative 1. It's just an inverse of that one. So the answer there, when you punch that in the calculator, your answer there, it will be 71.57 degrees. So that means this angle here, it's 71.57. But now you have to add the 71.57, 80, 90 most, 90, what am I doing? It's going to be 90, 180 plus this. So we'll say 180 this time. So therefore, we'll say 180 plus 71.57 degrees. It will give us the same answer as this one. It's going to be 251.57 degrees. I hope you get that, guys. If you don't get that, rewind it and watch it again. Now 2.3, it says use the component method to calculate the magnitude of resultant in force units for vector P and Q. Guys, let me erase all these. So guys, we wanted the resultant of the forces that are acting at this point for both two vectors, vector P and vector Q. So how do we do that? Now what we're going to do, we're going to, let's go back and erase what let me erase this and this and this and this and this. Erasing that. Yeah, so what I'm going to do now, I'm going to add all the components. So what I'm going to do in order to get the resultant of that, I'm going to add this x plus this x, and then I'll have the fx net, and then I'll do the y net with that, and then I'll do the theorem of Pythagoras now. So this is 2.3. I'll do the fx net. Fx net is made up of this fxq and fxp. So it's fxq plus fxp. The fxq, if you are looking here, it's going to the left. Fx, it's going to the left there. So what is the answer of f? It's negative 3. It's negative 3. So it's negative 3 plus the fxp is going to the right. Here is it, which is positive 2. So the answer here, it's negative 1 Newton, which is it's 1 Newton left. Now let me calculate the Fy net, adding all the y's. So it's going to be Fyq plus Fyp. Let's look at the Fyq. The Fyq, you can see there, it's going down. So it's 1, it's going down, it's negative 1. So it's negative 1 plus the Fyp, it's 4 newtons up, which is going to be positive. It's 4. So the answer there, it's 3 newtons where upwards, because it's positive, right? And then getting the fx and fy, we can draw the vector diagram with those. So we have the fx net, it's negative 1. It's 1 that is going to the left, and then the y is going upwards by 3 newtons. This is Fy net, and then your resultant there, starting from the tail of the first vector to the head of the last vector. This is your y net, and then that's your angle there, and you have 90 there. So very important for this, and understand which quadrant is this, where it's going to be your negative 1 of x. Negative 1 of x is there, and then your y, that is your y that is going upwards, that is positive, it's going to be there. So this, it's in this quadrant, right? It's in that quadrant. So that quadrant, guys, if you really understand what we are doing, that quadrant is which quadrant? Okay, let's calculate the resultant there. Let's calculate the resultant and leave the quadrants in the meantime. So so the resultant, we say f res, the resultant of what? Of p and q. So it's fx net square plus fy net square, using the theorem of Pythagoras. Very important, that one. 1 square plus 3 square. So that will be square root 10, and the answer is 3,16 newtons, right? Very important. They wanted the the magnitude of resultant, right? Now in the following question, they want the direction of the resultant q and p. They want the direction of this resultant, but they say it's very important, the instruction measured clockwise from the positive y-axis, but they want it in a bearing form. So as I've mentioned, this resultant, it's going to be here. It's going to be here, right? It's going to be there in that quadrant, because you have negative 1 and positive 3 there, so it's going to be in that quadrant. So they want the direction measured from the positive y-axis clockwise. It's going to be that. So they wanted this angle from here, so it's going to be 180, 270, and that. So the angle, it's more than 270. So basically you calculate this angle, or you calculate this angle and say plus 180 plus this angle, or you say you calculate this angle, you say 360 minus this angle, it will give you that. Let's do it. Excuse me. Right, so what we're going to do in 2.4, as I just explained now, so you say angle is equal to tan theta minus, so let's say we calculate, let's start with this one, we calculate this angle. So your opposite, it's this, which is 3, which is your fy net, it's 3 over fx net. So you use 10 there, it's opposite over adjacent. Your adjacent is this, which is negative 1. So it's going to be, this is going to be your y, it's 3 divided by negative 1. So when you punch that in the calculator, you will get negative 71,57 degrees. So what is the 71,57? It's this angle right here. So you will say 270 plus this angle that you just calculated, it will give you the entire angle, which is, that's the bearing. So you'll say therefore theta is equal to 270 degrees plus 270 degrees plus, I hope you get what I said. 270 plus 71.57 degrees, the answer is 341.57 degrees. Alternatively, as I mentioned earlier, if you calculated this angle, so that means you will say 360 minus this angle. It will tell us what is this angle. Out of 360, you minus this angle, which when you minus this angle, it will give us this angle, which is the bearing there. So now calculating this angle, you have your x there. These are your x. So you say have opposite over adjacent. So you have your tan theta. It's fx what? Fx net divided by Fy net. Basically, it's a reciprocal of that. So that means it will be 10 negative 1, which is negative 1 over negative 1 over positive 3. So the answer for that, it will be negative 18.43 degrees. So the negative 18, it's this angle here. So you say 360 minus this angle, it will give us this angle that starts from there to there. So you will say, therefore, the angle there, it's 360 degrees minus 18.43 degrees, and it's going to be 341.57 degrees. That's the end of the question.